Hi everyone, welcome back to Pine Hollow out of Diagnostics. We're on the road today at a shop here on the border of New York and Pennsylvania, and we have a beached whale Ford Excursion, 5.4 liter V8, over 200,000 miles, and it's been off the road for half a year. Apparently the owner already replaced the fuel pump, replaced the inertia switch, so I'm guessing it has a fuel pressure issue. Still broken, so now they towed it to this shop here, and the shop owner wants me to take a look at it. So let's see what we find. Alright, so obviously we'll start with a full code scan, and just as I was hoping, we do have a code for fuel pump secondary circuit low, P0231. So I've run into this before. I didn't make a video on the last Ford with this issue, but we're gonna get this truck back on the road, absolutely no parts required, in under half an hour. Let's take a look at some wiring diagrams and do some basic checks before doing the repair. Okay, so here's the wiring diagram for the fuel pump. So the fuel pump is right here, and it's fed by this fuel pump relay through the inertia fuel shutoff switch. Okay, so this fuel pump relay, in Ford's wisdom, is integrated into this central junction box. You cannot replace it. It's not a regular relay, it's internal, and you can't get to it. So if it goes bad, you know, fuel pump is a pretty high current item, about 10 amps, those contacts get pitted, then you have to replace the entire central junction box, which is ridiculous. So, you know, why does this code set? So when the fuel pump relay is energized, it sends power obviously to the fuel pump, but also on this wire right here, V power to the PCM. So the PCM actually monitors the output of the load side of the fuel pump relay, and if there's a problem, it'll set that 231 code. So it's commanding the relay on. You see the PCM's in charge of this relay. It probably clicks, we'll see if it does, but we have no power output right here. So that's the first thing I want to check. Get on this dark green and yellow wire at connector 270K at the central junction box and verify indeed we have no power output. If we don't, we can just easily jump power to here, you know, through a fuse or a 5 amp test light or something, see if this fuel pump comes on, measure the current, and then that'll be the diagnosis. We'll call this relay. So let's do a couple simple checks at this central junction box. Let's take a look at where the connectors actually live. So connector 270K is going to be right on top of the junction box there, and the pinouts, it's a 4-pin connector. Pin 3, dark green and yellow, fuel pump relay switched power output. So let's go there and measure the voltage on there. When we turn the key on, we can bidirectionally command the pump on, and I suspect we're going to be missing voltage on that output of the fuel pump relay. Okay, so I got the junction box exposed, and there's our 4-pin connector right there. You see the dark green and yellow wire. That's the fuel pump output, or output from the fuel pump relay. So here's our voltage right now. Let's see what happens when we turn the key. Turn the key. 5 millivolts. Okay. Let's we can crank it. Okay. Let's go into bidirectional controls in the PCM and toggle this fuel pump on and off and see if something clicks inside the box, but we have 0 voltage on here at the moment. Alright, here we go. Fuel pump. So we'll click on. You hear a nice loud click. On, off. On, off. Exactly like I expected. This was the same scenario on the other Ford truck that I did recently, but I didn't make a video on this one, on that one. But we're making a video on this one. This is a common issue on these Ford trucks, and I'll show you how to get your truck started with no parts required. Alright, so back to the fuel pump diagram. So where is the load side? We know the control side's fine, it clicks, but where does this fuel pump relay get feed on the load side? You see Y diagram 24-3. Let's go to 24-3. And there it is. There's Y. It comes from fuse F2.34, and that's powered up by this PCM power relay. And you can see this relay is labeled, 1, 2, 3, 5. So this one is actually replaceable. It lives, on top of the central junction box. Now, let's check fuse F2.34. It also feeds, something else on the next diagram, and that fuel pump relay. So let's put a test light on here, turn the key on, make sure that's powered up at the moment. Alright, so fuse F2.34 is going to be at the top of the junction box right next to this middle relay, and that's kind of hard to see. See, there's 3 fuses there. It's the closest one, that 20 amp. So let's stick a test light on there and see if it's hot on both sides. Yes and yes. So nothing wrong with the fuse on our diagram. So fuse 2.34 is perfect. It's feeding the load side of that fuel pump relay inside the box, but the relay, the contacts are pitted, it's shot. So pause the video here and think of how can we easily bypass that relay, no parts required, in a safe manner to get this truck back on the road. Okay, so we know that the PCM power relay, when that's on, it powers up these 3 fuses and then also the fuel pump relay after this fuse. Well, there's something else that actually comes out of the box that we can access. C270A pin 10, where does that go? It goes to J. So let's find J. That feeds the power to the mass airflow sensor, comes over here, and then feeds power to the PCM. Okay, perfect. So can we tie into this wire right here and jump it to, just straight up jumper, it's protected, it's on the same fuse, 2.34A. Instead of going through the fuel pump relay, how about we just bypass the fuel pump relay? So over here, we can just bypass the fuel pump relay altogether and go straight from Y to this dark green and yellow, which we're already tied into. Okay, so that's what I want to try right now. Go from C270A pin 10 to C270K pin 3, and then see if the fuel pump runs, if the vehicle starts. Okay, so here is C270A. It's a 12-pin connector, and we're looking for pin 10 red. So I found it right next door to connector K. We're on that red wire. Let's see if it's on right now with the key on. So you can see test light's lit up. That's perfect. If we turn the key off, that should go out. Key on, comes on. So now, let's just jump here and here with a 5 amp bulb just to be safe at first. See if the fuel pump runs even at half speed, and see if the truck will fire up. Alright, so you can see the test lights. So I connected those 2 pins. Now we're sending power to the fuel pump. Yes, there is a voltage drop across my test lights, and let's see how much voltage we're feeding to this pump. About 6 volts, so it should be running at half speed. It's definitely running, you can hear it. Let's see if this thing will just fire right up. That's it, we're done. As soon as you turn the key off, the fuel pump will shut off. So now the PCM isn't really in charge of that relay anymore. Well, it's out of the picture. So all we got to do is just jump those 2 wires together. Easiest bypass pack, your truck will run fine. It will actually be more reliable because the PCM relay is one of these big ones that you can replace, not the integrated one. So let's make this permanent, and then we can measure the current going through this fuel pump. Alright, let's see how much current the fuel pump draws. I'm going to turn the key on. About 5 amps. That's totally fine. And this should have full voltage on the pump now. Let's measure the voltage. Why am I not measuring the voltage? Oh, there we go. 13 volts on the pump. So, perfect. Let's just splice those two wires together, and yeah, it's safe. It's already protected by that fuse. All the current was going through the fuse to begin with, so you don't need to up the amperage of the fuse. It's a beautiful solution. No parts required, just a soldering iron and maybe a piece of wire. By the way, with the fuel pump installed, let's clear all the DTCs out and see if the PCM will fuss about the fuel pump. Will it set voltage high because it's not expecting the pump to run all the time and with the key on? Fuel pump secondary circuit high. So I don't know if that'll set a check engine light necessarily. You probably care about that. I mean, worst case scenario, you can actually wire in a relay, an external relay for the fuel pump circuit. All the wires are accessible. So we'll see what the shop owner wants to do here. So my question is, will that code trip the check engine light? Is it a Ford specific code, or is it an OBD2 global code, which will matter for emissions inspections in New York State? So let's do a couple key cycles, you know, run the engine. So service engine soon is over there by the fuel gauge. So check engine light's not on. And in OBD2 global mode, if you read fault code, no fault code. So that's fantastic. It's only being set that, you know, whatever fuel pump circuit high code is being set in the Ford global menu. So we can get away with the easy, quick and dirty bypass, no problems at all. And that's it. This Ford will be back on the road. No fuel pumps required, no inertia switches, nothing. Hopefully this video helps someone out. So let's make that final. I'll show you exactly what, you know, how I spliced the wires, and we'll call this one fixed. Okay, so all we want to do is make a jumper between the red wire and this dark green and yellow. We don't want to just cut the dark green and yellow connected to the red, although you could, because this is a sense circuit and we'd rather have the fuel pump circuit high code than the low code, even though it probably wouldn't matter. But the jumper will be easier to remove if they ever replace this junction box and they want to restore it back to stock. So we don't want to cut any wires, you just want to strip the insulation. So use the stripper, 14 gauge here and here. So you have a little section of insulation here that you can grab onto with pliers. Easier to do with two hands, of course. And we'll just pull that insulation off. Already exposed some copper on the red wire right there. And we'll just make a jumper, solder it on, tape it up, done. TS100. So you can see the jumper from here to here, just a short little guy. Let me heat those wires up, solder them up, and put a little electrical tape on there. No one will ever know that we were here. The truck will run perfectly. Okay, that's good. Put some right on here. Look at that. Beautiful. Let that cool off a little bit. Do a little tug test. You can still disconnect the connectors if you want. There's enough slack. Pull this tape back down. That's it. That's our repair. Just beautiful. All right, final shot of the repair. There's a little jumper. Wrapped it up in some tape. Let's fire it up. That's it. Plastic back in here. So that's how you get these Ford trucks from the 2000s. They all use the same central junction box, same integrated fuel pump relay. Quick and easy bypass, so you can do it yourself. And that's it. So thanks a lot for watching. We'll see you on the next one. Bye.